FMC cable can be installed on the surface of drywall in a residential garage. The National Electrical Code, or NEC, specifies requirements for surface metal raceways, including MC cable when used in this manner. Surface metal raceway must be secured in place at intervals not exceeding 6 feet. This means the MC cable should be stapled or screwed to the drywall at least every 6 feet. Flexible metal conduit, or FMC, is also permitted to be installed on the surface of drywall in a garage. However, FMC has an additional requirement: it must be protected from physical damage and not subjected to rough usage. The NEC does not explicitly define the type of protection required for FMC in this application. The method of protection for FMC typically involves securing it to the surface to prevent movement and potential damage. This can be achieved by strapping the FMC to the surface or stapling it. Understanding the NEC requirements for both MC cable and FMC is crucial for ensuring a safe and code-compliant electrical installation in a residential garage. MC cable, often referred to as metal-clad cable, is a factory-assembled cable consisting of one or more insulated conductors enclosed in a metallic sheath. The metallic sheath provides mechanical protection for the conductors and serves as an equipment grounding conductor when installed properly. MC cable is commonly used in both residential and commercial applications for various wiring needs. It is suitable for both concealed and exposed installations and can be used in dry or damp locations. When installing MC cable, it is essential to follow the NEC guidelines for securing and supporting the cable. The NEC specifies that MC cable must be supported and secured at intervals not exceeding 6 feet and within 12 inches of boxes, cabinets, fittings, or other terminal points. These support requirements ensure that the cable is properly supported and protected from physical damage. In addition to the support requirements, the NEC also addresses the bending radius of MC cable. The minimum bending radius for MC cable is typically 5 times the diameter of the cable. This requirement helps prevent damage to the conductors inside the cable and ensures that the cable can be properly installed in tight spaces. Flexible metal conduit, or FMC, is a type of flexible metal raceway that is commonly used for protecting electrical conductors in various applications. FMC is typically made of galvanized steel or aluminum and is available in various sizes and lengths. FMC is commonly used in applications where flexibility is required, such as connecting motors or other equipment that may vibrate or move. It is also used in locations where it is difficult to install rigid conduit, such as in tight spaces or around obstacles. When installing FMC, it is important to follow the NEC guidelines for securing and supporting the conduit. The NEC specifies that FMC must be supported and secured at intervals not exceeding 4.5 feet and within 12 inches of boxes, cabinets, fittings, or other terminal points. These support requirements ensure that the conduit is properly supported and protected from physical damage. In addition to the support requirements, the NEC also addresses the use of fittings with FMC. The NEC requires that fittings used with FMC must be specifically designed for use with FMC and must be properly installed to ensure a secure connection. It is also important to ensure that the fittings are compatible with the size and type of FMC being used. The NEC also addresses the grounding requirements for FMC. FMC can be used as an equipment grounding conductor under certain conditions, but it must be installed in accordance with the NEC requirements. In general, FMC is not permitted to be used as the sole equipment grounding conductor, and a separate equipment grounding conductor must be installed inside the conduit. The NEC provides specific guidelines for the size and type of equipment grounding conductor that must be used with FMC. When installing electrical wiring in a residential garage, it is important to consider the specific requirements of the NEC and any local codes or regulations. The NEC provides detailed guidelines for the installation of electrical wiring in garages, including requirements for wiring methods, overcurrent protection, and grounding. In general, electrical wiring in a garage must be protected from physical damage and must be installed in a manner that minimizes the risk of electrical shock or fire. The NEC also requires that all electrical outlets in a garage be ground fault circuit interrupter, or GFCI, protected. This requirement helps protect against electrical shock in damp or wet locations. When using MC cable or FMC in a residential garage, it is important to ensure that the wiring is properly installed and protected from physical damage. This may involve using conduit or other protective measures to protect the wiring from impact or abrasion. It is also important to ensure that the wiring is properly grounded to minimize the risk of electrical shock. The NEC provides detailed guidelines for grounding electrical wiring in residential garages, including requirements for the size and type of grounding conductors that must be used. In addition to the NEC requirements, it is also important to consider any local codes or regulations that may apply to electrical wiring in residential garages. Some local jurisdictions may have additional requirements or restrictions on the types of wiring methods that can be used in garages. It is always a good idea to check with the local building department or electrical inspector to ensure that your electrical installation complies with all applicable codes and regulations. When working with electrical wiring, it is important to take all necessary safety precautions to protect yourself from electrical shock or other hazards. Always de-energize the circuit before working on any electrical wiring and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to perform the work. A qualified electrician will have the knowledge and experience to safely and properly install electrical wiring in accordance with the NEC and all applicable codes and regulations. In summary, MC cable and FMC are both acceptable wiring methods for use on the surface of drywall in a residential garage, provided that they are installed in accordance with the NEC requirements. MC cable must be secured at intervals not exceeding 6 feet, while FMC must be protected from physical damage and properly supported. It is important to consult the NEC and any local codes or regulations to ensure that your electrical installation complies with all applicable requirements. Always take necessary safety precautions when working with electrical wiring and hire a qualified electrician if you are not comfortable performing the work yourself. The purpose of the National Electrical Code, or NEC, is to safeguard persons and property from hazards arising from the use of electricity. The NEC is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect changes in technology and industry practices. The NEC is not a law itself, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Compliance with the NEC is essential for ensuring the safety of electrical installations and protecting people and property from electrical hazards. The NEC is organized into chapters, articles, and sections, each covering a specific topic related to electrical safety. Chapter 1 of the NEC provides general requirements for electrical installations, including definitions, wiring methods, and overcurrent protection. Chapter 2 covers wiring and protection, including requirements for conductors, cables, and raceways. Chapter 3 covers wiring methods and materials, including requirements for different types of wiring systems such as conduit, cable, and surface raceways. Chapter 4 covers equipment for general use, including requirements for electrical appliances, lighting fixtures, and motors. Chapter 5 covers special occupancies, including requirements for electrical installations in hazardous locations, healthcare facilities, and other special environments. Chapter 6 covers special equipment, including requirements for electrical installations for elevators, cranes, and other specialized equipment. Chapter 7 covers special conditions, including requirements for electrical installations in emergency systems, fire alarm systems, and other critical applications. Chapter 8 covers communications systems, including requirements for electrical installations for telephone, data, and other communication systems. Chapter 9 contains tables and examples that are used to supplement the requirements in the other chapters of the NEC. The NEC is a complex and detailed document that requires careful study and understanding to be properly applied. It is important to consult the NEC whenever designing or installing electrical wiring or equipment to ensure that the installation complies with all applicable requirements. In addition to the NEC, there are other standards and guidelines that may be relevant to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or UL. These standards provide additional guidance on specific aspects of electrical safety and performance. It is important to be familiar with these standards and to follow them when applicable. The electrical industry is constantly evolving, with new technologies and practices emerging all the time. It is important to stay up to date on the latest developments in the industry to ensure that your electrical installations are safe and efficient. This can be done by attending industry conferences, reading trade publications, and participating in continuing education courses. By staying informed and up to date, you can ensure that you are providing the best possible electrical services to your customers. In conclusion, MC cable and flexible metal conduit, or FMC, are both acceptable wiring methods for use on the surface of drywall in a residential garage, provided that they are installed in accordance with the NEC requirements. MC cable must be secured at intervals not exceeding 6 feet, while FMC must be protected from physical damage and properly supported. It is important to consult the NEC and any local codes or regulations to ensure that your electrical installation complies with all applicable requirements. Always take necessary safety precautions when working with electrical wiring, and hire a qualified electrician if you are not comfortable performing the work yourself. Remember, the purpose of the NEC is to safeguard persons and property from hazards arising from the use of electricity. The NEC is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment, so it is important to follow. The use of electrical components needs to be up to date with the industry and with standards.